All right, I had you fill this out from the back to the front. What is the definition of porosity? Yeah. Good job over there raising your hand. Amount of hole space. Notice I did not say the size of the holes, and I didn't say the number of holes. I specifically say the amount of hole space. So it's almost like finding area. Okay, so it's not just the number of them or the size of them, it's the area of the hole space. So going down, how does size affect porosity? It doesn't. Size does not matter when we're talking about porosity. Don't get porosity and permeability confused. Speaking of, let's go up and do, how does size affect permeability? What happens if we have larger particles? Okay, water goes faster through, or higher permeability. You're willing to miss the review? Okay. Smaller particles go slower. And again, that means lower permeability. So size does matter if we're talking about permeability, but porosity does not. So again, permeability is just talking about how fast the water goes through. So if I had soil made out of big beads versus soil made out of little beads, and it rains, so I dump water on them, it will soak into the big beads faster. That's permeability. It will still soak into the little ones, just much slower. Again, that's permeability. But in the end, they will both hold the same amount of water because they both have the same porosity. So I hate this chapter because the words are so similar. Porosity and permeability, the words should be so different in my opinion. Permeability is just how fast the water goes in. Porosity is the amount of hole space, or in other words, how much water they can hold. In the end, they'll both hold the same amount, porosity, but it'll soak in faster to the big beads because the openings are bigger. That's porosity and permeability. Be careful with those two. If we want to increase runoff, by the way, if we're having increased runoff, what's not happening? Not soaking in. So what are the things that will cause water not to soak into the ground? Okay, a steep slope. Okay, if the ground is already filled up, which is called saturated ground. So if the soil's already filled up, you can't add more to it. So it's going to run off. What else? Okay, so if the ground is frozen. If the ground is frozen, like an ice rink, and you dump more water on top of it, it's not going to soak through until the ground melts. What's another time water will not soak in? So in other words, it runs off. Yep, if the ground is impermeable. For example, in cities, the ground is more impermeable in cities made out of roads, buildings, parking lots, no grass, in other words. The less grass, the more runoff. And then the last one, it might be hard to put into words, but when it's raining really heavily, raining too fast, for the water to soak in. For example, again, if it was raining on this small bead one, it takes the water a long time to soak in. So if it's downpouring, the water's going to pool on the top of it and then run off before it can soak in. Yes, it will soak in eventually, but it takes time. So in the meantime, we're going to have runoff or flooding. Everybody comfortable with when water runs off? Okay. 4 characteristics of the soil that will cause the highest infiltration rate. What will cause that water to be able to soak in really good? The shape. What shape? Rounded particles. With another thing. Yep, so size, large particles. What else? Oh, sorry. Yep, thank you. Remember, if they're mixed, if I was to mix these big beads with the little beads would fill in the holes. So then we would have not good holes for the water to soak in. So it'd take a while. And what's the last one? Yep. Loosely packed. The looser they are, the more holes there are for the water to go through. Sorted, yep. So sorted meaning all big ones in a container versus mixed with big and little ones in together. Capillarity action. What's the best characteristic of the soil to have capillarity action? Smaller the better. Why? So first of all, the way I remember, who said why? Okay, the way I remember, at least, so I know this isn't answering your why, but how do you remember? Is that capillaries are the smallest blood vessel you have, like the teeny tiny veins in your eyeball. So that's how I remember. Capillarity action, capillaries, tiny. Why? The official science, which is technically something you don't need to know, is that water likes to stick together. So if it's able to stick together in a small hole, it'll actually stick together and move up. But again, just remember, because capillaries are small, capillarity action happens best in teeny tiny particles. What processes in the water cycle will raise the water table? So remember what the water table is. That's on page 9 of your packet. So your water table is how far down you have to dig to get to the water. It's the top of the saturated zone. So if we want that to rise, meaning going up in the ground, James, what do we have to do? What do we have to do to raise the water level? Yeah, you got to add more water, which means it's got to rain more. So more water. So in other words, we need rain or precip. The opposite of that, how will we lower the water table? Or in other words, take the water table from near the top of the ground and make it drop. So you have to dig a deeper hole to get to water. What happens? Do we need more water? No, you clearly need less water. And what processes in the water cycle take water away? Yep. Evaporation. Sorry, I can't spell. And not just evaporation. There was another one we learned this year. Transpiration. Was there any more? Nope, those are the only two that I believe. Now, just to make sure you understand the concept, if soil has a high permeability, that means the water will, what's the water going to do if it has a high permeability? Okay, it means water can go through fast. And the higher the permeability, what happens to runoff? It will decrease or it'll be lower. We'll have less runoff when we have high permeability. Then the other side of that, if we have low permeability, what does that mean? Right, it means water cannot go through, or at least go slowly. And the slower or the less water that can go through, what's going to happen to runoff? Yeah, we're going to have more runoff. I just realized there were a couple vocab words that are still on the quiz tomorrow on the front. These bottom boxes. What is evaporation? Water goes up. What's it start off as? Okay, starts off as liquid. And what's it turn into? Turns into vapor, which is gas. What's transpiration? Plant sweat. As long as you know what plant sweat is, I'm good with it. It's just water evaporating off of plants. So it's really not that high tech. It's still water being evaporated, hence the ation part. Water evaporating off of plants. What's condensation then? This is when the gas water goes to liquid water. This happens in the clouds or fog. I don't know if we need the definition of precipitation, but most of you will just say rain. Precipitation is rain. Keep in mind it's any water. Falling from the sky. What's runoff? What's runoff? It's water that does not soak in. What's infiltration then? This is when water soaks into the ground. And the last box for the quiz tomorrow, permeability. Ability of water to flow through ability of water to flow through a material, and then permeability rate is how fast water goes through.
Why would they make two different words?
They are the same word. They are basically the same thing. And we did talk about how they're basically the same thing. Any specific questions for the quiz tomorrow? No, you will not be using these review sheets on the quiz. I did look through the quiz. I'll tell you for sure, you need to know what evaporation and transpiration is. I'm assuming you already know what the word precipitation means, but that is on the quiz. You absolutely need runoff, infiltration, permeability. Technically, I guess permeability rate isn't on there, but it's a concept you technically need to know to be able to answer questions. There is a question about porosity. There is a question about capillarity action. You definitely need to know when runoff is great and when infiltration is great, which also goes along with these bottom two questions or boxes. Porosity, capillarity action, when those are best. And yes, you need to know about raising and or lowering the water table. Oh, yeah. And you definitely, you need to know all of the ones we just did. Yeah. Well, so I was trying to just double check, and yes, you need to know all of the boxes we just did. Some of the boxes are the same. Like these two last boxes, we covered in other boxes. You just need to make sure you understand those concepts. Any questions for the quiz tomorrow?
No.
In case you care, it is 10 questions long. There are 6 multiple choice, and then the other 4 are short answer / graphs. Okay. You guys did not get on page, we didn't go to page 14, I don't think, in your class. So we're gonna do the notes on pages 14 and 15 today, and then we're done and you have no homework. My other classes did already get page 14, so you're only 4 minutes behind maybe. Yesterday we talked about ocean currents. Everybody like up to date on ocean currents? Not you.
What page are we on?
In your packet where this is page 13, we're gonna start page 14. So with ocean currents, the questions are super basic. Like what ocean current is affecting the west coast of the United States? Or is the ocean current that's affecting the west coast of South America a warm or a cold current? So in other words, just looking this stuff up on your reference table on the map on page 4. So now we're just gonna switch over to wind belts on the back of 13, so sorry, page 14. I hear that those of you who had this round have wind belts already down pat. Those of you who had Mr. Ronan, is that the other one?
Yeah.
Okay. Did you also know this stuff? He just wasn't quite as enthusiastic as Mrs. Brown was. What? How dare social studies and science interact? I hear Mrs. Brown was a huge fan of monsoon. Monsoon. Strong seasonal winds. Mrs. Brown ingrained that into your brains that a monsoon is a strong seasonal wind. And he talked, I know he talked about it. It was a concept that you needed to know last year. But those of you who had Mrs. Brown know that you had to repeat strong seasonal winds every time she said the phrase monsoon. So this was talking about the weather in India, correct?
Yes, sir.
Right, I have not taken her class, so I'm not sure. Yes, it is, okay. So she was talking about climate in social studies. Weird, but the key is there is what controls the climate in India?
Monsoon.
The monsoons, which are strong seasonal winds. So one of the last factors that we have to talk about that controls your climate are the wind belts. 3 times?
Tuned his guitar 3 times.
Oh,
It was
Mr. Roddick?
still whack, yeah.
yeah, well, that has nothing to do with mine.
Miss Rich,
Well, that's what
you
we
wanna
need
give
to solve.
something?
Oh, there was songs?
You're giving me first to me,
Miss
I.
Rich, Miss Rich.
Don't even get me started on that eye
You wanna hear what I did to get out?
No, I do not, because right now, no, I told you no, let's keep going. Page 14, wind belts. They are caused by the rotation of Earth. We also know that the winds blow from regions of high pressure to low pressure. This is called the Coriolis effect. This is what we talked about. It was only like a week and a half ago when we were talking about throwing the football to a runner who's moving. So the Coriolis effect is that apparent bending of the wind due to Earth's rotation. The wind belts will bring the weather from where they're blowing from. So with India, if they were coming off the mountain, that was during the dry season in India. And then when the wind shifted and blew from the ocean, that brought with it the monsoon. Have you written this yet? Oh, yeah, that whole thing. I know because you're not paying attention. I know, that's why I want you back in your seat, so you're not in your own. So as long as you remember that winds can control the weather as well, you already know the basics of the wind belt. I would like you guys to grab your reference table, open them up to page 14. So on page 14, you'll find this reference table, which we did already partially look at last chapter. This is a map of the globe. This map only shows us latitude. So we can see the latitude, the equator is 30. No, sorry, the equator is not 30. The equator is 0 degrees. They label 30 north, 60 north, 90 north, and they label those same ones going south. There is no longitude on here. So remember, the world is spinning. So at any point, you could be anywhere. You could either be here, 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 or here on the globe, or on the back of it. Because we don't know when this, like where this is longitude-wise, only a latitude. What we need to remember with this map is you need to be able to label the highs and the low pressures on this map. And I gave you a very similar one in your on your notes that I want you to label. Now, I already labeled this, but how could you have looked at what was already there and your reference table? So if we looked at this reference table, how do we know it's a high pressure up here at the North Pole? One reason is because it's dry. High, dry, cool, clear. So high pressure is dry. No, right here they aren't showing the clockwise here. But there is something else that is on this map that tells you the North Pole would be a high pressure. Think Bart. The wind is going out of a high pressure. The wind always goes from high pressure to low. So on this map, or a map like the one you have in your reference or on your packet, the high is always at the butts of arrows. And again, Bart, come from your butt. So high pressure is always at the butt. So let's label the high pressures on your packet. So all the butts of the arrows get highs. all the heads of the arrows should get low. So if you haven't already added the H's and the L's to your packet, please do that now. And unfortunately, we're just a smidgen behind, so we need to keep going. And the last thing we're going to do is talk about how mountains will affect the climate of areas that aren't even just at the tops of them. So here we have a mountain. And the wind is blowing. They will always label with an arrow, or maybe in the reading, they'll tell you the wind is blowing from the west to the east. They'll always tell you which way the wind is blowing. The side of the mountain that the wind is on, that's called the windward side of a mountain. So the windward side is the side of the mountain the wind is blowing like towards. The leeward side of the mountain is the other side of the mountain. And yes, you will need to know the difference between the windward side and the leeward side. So on the windward side, the wind is blowing towards the mountain. What does the wind have to do when it hits the mountain?
Go up.
It has to go up. Wind cannot go through a mountain. It can't go under a mountain. So the wind has to go up. And what do we know with air when it goes up?
It's cold.
It does get colder. So when wind goes up, even if it wasn't warm air, normally it's only warm air that goes up. With a mountain, all air has to go up. And like Logan said, no matter what kind of air it is, when it goes up over the mountain, it's going to get colder than it already is. What do we know happens when air gets colder? What? Okay, guys, remember? Warm air can hold more water than cold air. So no matter what kind of air is going up, it's going to get colder. So it's going to be able to hold even less water than it's already holding. So in other words, the windward side of the mountain, as the air is going up, it's getting colder, hitting its dew point, and rain is happening on the windward side of a mountain. The other side of the mountain, the leeward side, once the air gets to the top, what's the air going to do? Go down. And when air sinks, what happens to its temperature? It gets warmer. And warm air can, first of all, it's already emptied all of its water out. But again, warm air can hold more water. So this side's going to end up being less humid or very dry. And this process is called orographic lifting. So topography, which is mountains will cause adiabatic cooling. Remember, warm air rises, it cools. So on the windward side of the mountain, what happens is wind pushes the air up the side of the mountain. As it goes up, it expands and cools. That's called adiabatic cooling. Warm air or cool air can't hold as much water, so it rains. Have you ever heard of the Napa Valley in California?
No.
Napa Valley in California is known for its lush greenery, wineries, lots of grapes. Why? Because they get the perfect amount of rain because they are on the windward side of a mountain. The other side of those mountains, anybody know what's on the other side of those mountains in California? That would be Death Valley.
Very warm.
What do you know about Death Valley? It's really hot there.
Very warm out here.
What?
Very-
Death Valley is a desert. Really dry, really hot. It's on the leeward side of those same mountains. So we do need one more slide after this, and I know we are running out of time. This is gonna go underneath the mountain picture,
Okay.
and that's talking about, so I want you to title that underneath orographic lifting. And on that side, the leeward side, air is compressed. usually dry and warm. The windward side of the mountain is cool and wet. Huh? I'm not going to be here tomorrow, so take a picture of it. You need these notes for tomorrow after the quiz. So I do know we're running out of time. Does anybody need me to go back so they can take a picture of the other slide? Grab your phones. Or just right, but you are out of time. So you have no homework tonight. Quiz tomorrow. You got it, really? Quiz tomorrow, and then you're gonna practice climate information after the quiz. I did.